Hello everyone, today I will be continuing our concepts that we have discussed of electronic configurations from the previous video that we discussed regarding the Aufbau's principle. In this video I will be discussing the Pauli exclusion principle as pertaining to filling in energy level diagrams of elements that we have discussed in the previous video, using those as our examples. So as you can see here, I have drawn out this energy level diagram. As you can see here, well, it's an energy level diagram of three separate scenarios. Now I'm going to be going through each scenario and discussing if it pertains to the Pauli exclusion principle, because it's very important. You need to follow this in building energy level diagrams and showing how the electrons look like in each subshell. So here, as you can see, you have one electron that's up and one electron that's down. So they have opposite spins. So this Pauli exclusion principle states that no two electrons can have the same set of four quantum numbers. So no two electrons. No. So I'm going to make sure you know that. No two electrons can have the same set of four quantum numbers. Same set of four quantum numbers. Oops, that's not how you spell numbers. Numbers. So what are quantum numbers, if you may ask? So quantum numbers I have discussed in the previous video. I discussed two of them. I discussed what N and L was, and N was the principal quantum number, and L was the angular momentum quantum number. And so the other two that I have not mentioned yet, so let me just write it down. So we have, so what this means is we have N, we have L that I already talked about, and we have MS and L. Now, MS and ML, let me put it over here. MS and ML are the two I haven't talked about yet. And so MS is known as the electron spin quantum number, electron spin, and the ML is the magnetic quantum number, magnetic quantum number. So the electron spin pertains to the orientation, so this here pertains to the orientation of the spin electron, if it's up or if it's down. And its value of each of this here, this is going to be plus 0.5, and this is going to be minus 0.5 because it's pointing downwards. So this is the value that this MS presents. So it's going to be from plus 0.5 to minus 0.5 pertaining to these electrons here. Now, ML is just pertaining to the orientation of the orbital in space. So this is what ML is. But we're more focused on MS over here. We're more focused on this pertaining to, in accordance with this Pauli exclusion principle, as you can see here. So, if you're wondering, why does it matter that they're in opposite states? Like, why is it important? So, if they did not have the orientation of it being the opposite of each other, these two electrons would possess the same identical quantum state, and that is not allowed according to this principle here. That is not permitted. So, electrons, I want to note, electrons are also known as pheromones. And pheromones are a particle that follows a certain statistics that has half odd integer spins. So that's what pretty much it's referring to. And pheromones, they obey the Pauli exclusion principle. So that's what's important here. Now, that being said, pheromones cannot have the same state. And if they did, then exchanging these two particles, if we had this be the same, then you would have no change to the overall system, and that's not what we're looking for here. So we want to make sure that they have opposite spins according to this principle. So I'm going to go through each here and see and tell you if it obeys Pauli exclusion principle or not. So let's get this ugly arrow out. So here we have spin up, spin down. So we know that this, so I'm going to just draw a line pertaining to each energy diagram here. These are 3 scenarios. So we see spin up, spin down, but we see these 2 spins that are up. This doesn't follow the Pauli exclusion principle because these 2 quantum numbers are the same, and this is not permitted. How about this one? This one is permitted because we can see that we have 2 separate, we have these electrons, all these 4 electrons, 2 in each orbital, have different spin values, have different spin orientations. So we can say that this follows Pauli exclusion principle. Now this last one down here, obviously these 2 are spin down, whereas these 2 are opposite. Now this doesn't follow the Pauli exclusion principle either, so we say this doesn't. But this one follows the Pauli exclusion principle. So this is what we can see from this point of view.